Hello guys, welcome back. My name is Angel. This is a new episode of Dev++. Today's episode is going to be about managing errors and exceptional situations with, exceptions. This is an effective code, a good practice that I use across all the years. Let's check out what I wrote here for you, right? So basically, this is the explanation of this convention, right? I will say the more than a convention or more than a style. I like to set it up as a rule for code bases where I work with and I interact with, right? Basically, every language, every popular language at least, has a way of managing errors. And normally, those errors or those exceptions, like some languages call it, are specifically designed in order to make the system or the runtime of the language to throw the errors with contextual information such as the stack trace, name of the error, any message that you pass, or any information that the language wants to send, in the case of APIs or native modules of the language, right? So with that being said, it's a common mistake for new developers or developers who have little experience working with other developers in large code bases or collaborating with other developers, or that they don't have that many experience designing APIs, or they are simply new on a programming language, to avoid use this type of constructs, right? And replace those constructs with simple values such as like zeros, null, voids, or give a special meaning to those really rare values in order to communicate that a function threw an error or that something is not okay, right? So I'm gonna give you a couple of examples here on JavaScript regarding how this looks like, what you probably shouldn't be doing or should be fixing if you already done it or you're seeing it. As you can see here in this do something heavy function, there's a couple of statements here that can throw different errors, and simply we hide the error that was thrown on the function and return simply a false, right? So if someone were to use this function, right, and something went wrong with either the file, reading the file, or parsing the file, or counting whatever content the file has, remember these are just like imaginary functions, we will receive a false, to communicate, well, the file was not found, or the file has an error on it, or we were unable to count the file just because the function maybe has a bug or something, and we just return false, right? So as you can see here, we don't communicate anything to whoever is using the function, either external users of the function, other programmers, other developers, or simply the user who's using the app. We just return a false like, hey, we couldn't do it, right? Which I think personally is a very bad practice. It's something that you shouldn't be doing, because you don't provide any information on what went wrong, so it's very difficult to debug and reproduce, right? Some more example here, like making a division by zero, right? Simply returning zero instead of throwing an exception. This doesn't really provide enough information. It doesn't tell the user that b is zero. Maybe the users of this API are assuming that that value is never going to be zero, and then you just hide or mask like an exceptional situation, right? So just to summarize here, right? Difficult to debug, right? We don't provide enough information. We don't communicate to users of the function what's going wrong. So it's not 100% clear why the exceptional situation was generated, right? Just because we're trying to hide that with a simple value. We're masking different types of exceptions in a single value, so that's not properly either, right? Also, you're forcing a function to have like this polymorphism, right, of type polymorphism, in order to return like a zero or a false, meaning that if you were to return like a specific object or a specific structure, you now have to also add to the return values like a zero, a number, or a false for a boolean, or maybe a null or a void depending on the language. So you have to provide like additional mutation of the return type for the function just because you're not using errors and exceptions properly, right? Promote a value for being used as an error, like the false or the zero that we're seeing there at the top, right? If you're saying that false means that there is an error, then your whole API or your whole code base will have to, be consistent. Meaning that in the case of you having a function which it actually will return a Boolean value, such as true or false, then you're saying that the false value may be a mistake, maybe an error of the function, right? So it gives you that trouble, right? Also, just to reiterate, the user of the function doesn't have any information on what went wrong inside the function, which is a terrible practice if you ask me. So a good way to solve this, first of all, spread the statements into, if they throw different exceptions, they need to be handled individually, right? Again, exceptional scenarios, they need to be handled exceptionally, right? This could also be change of, hey, if we cannot find this file, maybe default to a second file or to another file that could be found remotely or something like that. In this case, I'm just throwing in a specific exception. Provide enough information on the exceptions. In the case of JavaScript, any error or any exception, it has a built-in stack trace. So whenever you log an exception or you throw an exception, you will see exactly where it happened, the line and everything. Then you have the function. Same thing here, managing exceptions individually and, properly. And that way, users of the function receiving an error will know exactly what went wrong, right? Maybe a catch-all function if we know that this is throwing an exception and we don't have any use case or anything that we can do to recover or any more information to provide to the user, we just propagate the error, to the next caller of the function, right? Similar here with the division by zero, if we find that this is the error because there could be multiple errors doing a division, maybe too many decimals, maybe an overflow of the number type of JavaScript. But in this case, if we catch the division by zero, we just throw the new error and provide more information, right? So just to summarize this, well-designed API must be sensitive to how a user provides value to it, meaning that wrong value should be, should throw an error, it should break things, right? Because users of your API, they need to, be robust about using your your functions. Again, if you return a value that is not the expected type of the function, specifically for these dynamic languages such as JavaScript, the user of the function will have to test the values to see if it's an error or not, right? And just to reiterate there, if you're expecting a list or you're expecting a complex object and you get like a false or a zero, it's just not a good design to have like that sort of multiple types being returned by a function. It is possible, of course, it's that dynamic language and even in type language is possible, but it's just not a good design. Values that mean some more thing that are not errors, such as false, null, none, void, whatever, they are not designed for representing error scenarios. They are not designed for representing exceptions. That's why errors and exceptions are designed for. So use that instead, right? Raising exceptions, back to the first thing. Usually, this is very common in most of the popular programming languages. Raising an exception breaks the function, stops the functions. So this allows you to be consistent to the return type, right? So if it is a list, you always return a list unless you raise an exception, right? Of course, an exception in an error provides contextual information. We talk about this. You can include messages. You can include a specific type for naming your errors properly, which is also a good practice. And also it includes automatically the stack trace of your function called stack in order to better debug or better identify what was the chain of calls that generate that error, right? Of course, also related to the types, you avoid boilerplate code where the user always have to compare values for specific functions and differently. in order to identify errors, right? When I mean differently, I mean that if a function returns false in one case for an error, in a different function, when it has an error, it doesn't return false, or instead it returns 0, then you have an inconsistency there, and just think starts to get ugly, right? So this is it. I'll publish the link to this article if you want to give it a read. If you enjoy this content, if you like these videos, please hit the like button. Leave any comments relating whether you agree or not with this strategy. Remember, this more than a style and a convention. This is something that I like to enforce in the code bases that I work with and with the people that I work with, just because I think that I think that being homogeneous and consistent is a really important part of creating effective code. So thank you for watching.